In this tutorial, we will learn about ICs. So ICs are the subcircuits, predefined subcircuits that are declared using this command, and you can find the IC names along with the descriptions in this table from the Zebra user manual. So how they are declared in the main program? They declared in the following way. The syntax is subsecurity space IC followed by the IC number, and then the pins are declared. So this is an example of IC7400 as shown here. So there are 14 pins, and as you can see there are 14 arguments here. These are the 3, 3, 6, 3, 9, and here are 5. So 9 plus 5 equal to 14 total arguments. And as you can see, this is 7th node is the ground node, so we'll have to fix voltage as 0 here, and this is the plus VCC pin. So at this node we'll have to fix the voltage state as 1, and the rest will have to fix as they needed. So these are the NAND gates, 2 input NAND gates. So this is the reference node for pin 1, this is the reference node for pin 2, and this is the reference node for pin 3. These are the inputs of the 2 input NAND gate, and this is the output. Let's see how it is used in a circuit. So we will perform the circuit with this IC, the 74151 IC, which is a 8-to-1 multiplexer, and let's see how it works. So this is our program. This starts with the main circuit and ends with in main circuit command, and we'll perform a two-step analysis on these nodes. So let's see what these nodes do. For this purpose, we will bring the diagram of the IC. So this is the first node, which is D3. This is the second node, which is D2, D1, D0, and this is the Y. The output node is 15, and this is 16 is the Y bar node, and this is the opposite of enable, that is E bar node. The 18 is the ground, and these are the select lines S2, S1, S0. These are for other inputs, respectively D7, D6, D5, and D4. And this is the plus VCC that has to be set to 1. This is where it is set to 1 plus VCC. This is where the ground is set to 0, and this is where the opposite of enable is set to 0, such that the enable will be 1. And the truth table analysis will be performed on the select lines and the inputs. And finally we will print the data in the form 19, 20, 21, which are the select lines. Here the nodes are referenced as the pin number plus 10. So these are the 9, 10, and 11 pin. 9, 10, and 11 pin. So this is the least significant bit, and this is the most significant bit in the select lines. And these are the inputs that is printed later. They follow the order D0, D1, D2, D3, D4, D5, D6, D7, 14, 13, 12, 11, 25, 24, 23, 22, and this is the output pin. So let's simulate this circuit. Zebra IC.txt. This is the analysis type, truth table analysis, and the number of nodes are 51, and the input nodes are here. These are the select lines, and these are the input lines. Let's start the simulation. There are 11 nodes, so the simulation will take time, and let's see how it does. This is a long simulation, so it is impossible to check every data here, but we'll check it randomly. So let's see how these data work. So these are the 100, that means d2 this is 2 to the power 2, so d4 will be redirected to the output in all of these cases 100 till here. So this is d0, d1, d2, d3, d4. Let's see if this column matches this column. 0 0 1 1 0 0 1 1 from here to here. So yes, they match. They totally match. Let's see in another place. So these are the 101. That means this is 2 to the power 0 and this is 2 to the power 2. So d5 has to be matched with the output here to here. So this is the d5, d0, d1, d2, d3, d4, d5. This has to match with this, and from here to here 0 0 0 0 1 1 1 1 0 0 1 1. So yes, they match. So we can see that the simulation is okay and the circuit is okay and the circuit works. So this is the end of this tutorial.